Hello everyone, this is Teamwork Studio and we're doing a presentation on machine learning and how to do that specifically with Raspberry Pis or small devices that have low computation power. So what is machine learning? Well, machine learning is been there in various shapes and forms for a long time. You might think it is something very futuristic, but it's already there and has been there for some time. Like things like spam filters that you might be aware of are key applications that use machine learning on a daily basis. There are many kinds of algorithms that are machine learning, and there are many approaches around machine learning. There's many kinds of classifications like supervised learning, unsupervised learning, and instance-based learning. So this is a very deep conversation on machine learning and where its usage are. But what we can focus for today is how do we use that in a Raspberry Pi, and how can we utilize a very simple program that can show you how facial recognition can be done on a Raspberry Pi. So the first thing is you might need to have to do some setup work, right? So our target is that we should be able to use an image and see wherever, like if I give you this challenge, where is this image of Waldo, and the Waldo is actually sitting right here, how do you kind of recognize contours and figure where this person is? Uh, it is an old algorithm. It was written by, and it's used by cameras, as you might know. When you focus using a camera, it shows a green line. It is able to detect faces like this or like this. So it is utilized very much. The algorithm basically uses these features called HAR features. HAR is a typical way that you can grab information from a face. Um, the whole idea is you have cameras. The webcams are having buffered images that are coming again and again very quickly, sometimes 30 to 60 times per second is getting refreshed. It's like taking very quick snapshots. While you are doing that, um, if you use colors and you kind of taking one picture within that 1/60th of a second, you got to figure all these contours of a face and then say, hey, this is actually a face. So how do we do that smartly, especially on very low compute devices like Raspberry Pi? The way to, so first of all, is there a pattern that you can see and use mathematics to do it very fast? So you can start kind of comparing colors and see if the shading or gradations are similar, but there is even more shortcut ways, and that's where HAR comes into the picture. So if you look at a person, you will know, kind of benefit from knowing some basic rules about faces. One is your eyebrows are always darker than your eyes or other parts of the face. So you can think of a rectangle which is black and white like that. Your nose is always closer to a light source because it is closer compared to the rest of your face. So imagine another rectangle which looks like this. Um, then you have other things that you can use. So there's some HAR features like that are basically rectangles that you can quickly operate on a buffer, video buffer, and quickly get to, okay, where is the face in this picture? So we are going to use something like that. The HAR features are a key way that people utilize it in a very fast-proof way. There are other optimizations that are done, like this ADA boost algorithm allows you to kind of use machine learning where you have classifiers. So you have lots of faces of different kinds of faces out there, and woman faces, man faces, kid faces, all these faces, and you kind of use machine learning algorithms to take a whole set of uh, data like that and then have false images and true images and get the algorithm to automatically learn from that. Once this is all done, you get a file which is a classifier file that we can utilize, and then kind of with almost near certainty say, okay, this new picture that I got is kind of matching some of these patterns. So OpenCV is a very, very popular library that almost nearly 20 years now has been written and is the basis for many, many platforms, hardware platforms, and software coding that is done using OpenCV, which is a computer vision, open source computer vision. It's originally written in C++, but has a lot of new Python bindings and other things. So we're going to be using OpenCV as a library and then utilize that for doing machine learning. So one more time, essentially what the machine learning process did, at the end of it, created a file that is available for use. And those cascade files look like this. If I it's a whole set of XML data information. So what we're going to first do is set up the environment. So setting up a Raspberry Pi, as you very well know, you can choose a Pi which is Model B or higher. Nowadays, there's Raspberry Pi version 4 available. You can use that. You can buy that from Amazon. So you could, let me show you that, which one it is. You can go to this particular kit is a nice one to use because it comes with a card, a heat sink, power supply unit. So this is a Raspberry Pi 3B B plus with a clear case. So it also has a case that will protect your Raspberry Pi, and it's not very expensive. It's about $60. You would require a screen, a monitor, or you could use something called VNC, like I am right now, using my own computer, but I'm logged in through the VNC. It's like remote desktop. So I'm able to remote into my Raspberry Pi, which is on my network, and I can go and work with it without affecting it. I don't need a spare monitor. I can use a computer to do that. So you could use something like that. Okay, so the other thing you need absolutely is something called a Pi camera, because we're going to use a camera, a cheap camera. So it looks like this. It is having a long cable at the end of it, and that needs to go into the Raspberry Pi like this, right? So you need these two. This costs about $25. So that's the cost of what you will need here. So we need Pi camera and Raspberry Pi. Or you could use the higher number this is, the version number, the better, more powerful the processor is, the more smoother your facial recognition will work. So nowadays there's also a Pi 4 that became available. You might want to choose that as a unit. How do we connect this, the Pi camera? You need to make sure that, so there's an HDMI port. If you look at it from this side, the side that is facing the HDMI port should not have the blue tape. It's the other side. This is the flipped side. That should actually look at the audio input. So that's how you would flip. You would basically, there's a little lever here that you would choose right here. You will pull it up, slide the cable in, and then push this lug down again. Just push it down again and it'll lock itself. That's how you would be able to use a webcam. Now the first thing you would do after that is to test it. So once your Raspberry Pi camera is up, Raspberry Pi is up, you are able to connect to it, you will get a screen like this. You can always go here on the very top and look for preferences, and go to Raspberry Pi configuration. Once you open that, you will see that you have this interface that comes up. This interface allows you to go to various things in here. I have already enabled VNC and SSH that allows me to connect to the Raspberry Pi through my Wi-Fi. But then this is important. You must check on the enable this. By default, it is not enabled, so you must check this and then click OK. Once you click OK, you should reboot. It will automatically ask you to reboot, so do make sure that you reboot after this is done. You can come here, shut down, and reboot the server. So now that once your Raspberry Pi is rebooted, you are ready for the next step. We went through this. Next step is looking at the Python environment, because we're going to use Python as the programming language of choice. So what you can do is go to right here under programming and look for Python. Usually all the Raspbian installations for Raspberry Pi have already a preset idle Python 3 or Thony Python, one of these editors already installed. So you can just go there and click on it, and you would get idle, which is an editor, and this editor lets you type code. You can say small, like hello world, things like that. So if you have small Python programs, you can do it right here. One important thing right now is we haven't really installed the OpenCV library yet. If I would have to go through that step before I can go and do anything to do with facial recognition. So one thing that we must do though is to see that the camera is properly installed. So how would we test that the camera is on? In order to write programs in Python, you don't use the shell, but you go to File, go to New File like this. Once you have a screen open like this, you can quickly go and create. I have a existing one, a test camera program. What it does is it can check just like this, print. I'm just commenting these things out, but I would need to write something like this. Include the library for Pi camera. That means you import it. You give it a name like Pi camera small. Then you also import the the library called time. From there you import the sleep command. So, and then you can enable the camera. You make an instance of camera by calling this Pi camera method. Then you say start preview and stop preview, and give it 10 seconds to adjust itself. This is a very small, this is not, this will allow you to adjust and take a video snapshot. So once you run this program, you will see what happens. So I would be able to just to run like this. And it would be able to test your program, and you should be able to see it on the screen. So make sure you test it and be satisfied that your camera is actually working. This is a very important thing. So once your camera starts working, you can go to the next step. We just discussed this. The most important thing for us to use computer vision is having this library set up. So in order to do that, you go back to your Raspberry Pi, open up this terminal window like this. And this is where you can list your programs or go to desktop, and so you can create and use the terminal window right here. So the first thing we want to do is open terminal window Linux and write these commands: sudo apt update. What these three commands will do is Python programs and packages out there on the internet allow, like we'll have to kind of pull the OpenCV library from the public domain. In order to do that, we need something called, so this first command, sudo app update, really updates your Raspberry Pi library. It's possible that you got an older Raspberry Pi and you're not up to date. This will just update all the library systems that are on the Raspberry Pi. The second command goes to a location and pulls engine called pip engine. The pip engine is a very convenient way of pulling Python libraries, entire roles of libraries to your Raspberry Pi. So this get command will get you the pip engine. The minute you have that, if your pip engine, once you run this program, you would be able to use the word pip like this. And pip allows you to use commands like, you can say sudo pip install. So this alone is enough for you to start. So if I copy this and I move it to my terminal window, sorry. So I can use a command like this, sudo pip install. Because I have installed pip, it's going to go and make a call over the internet and get this. I already have it installed, so it says, okay, this is already set up. But in your case, it might take under a minute for you to get this installed. Once you have this installed, that means you have OpenCV. The best test is, you can say import CV2, which is computer vision version 2. If you get no errors here, that means you're all set to go. That means your library is installed. The next step would be for you to go, so we just covered this. The next step is we have to create a directory. Let's create a folder on the main desktop. You can use the this tool on the very top. Go to desktop. Once you are there, you can create new folder, and you can create a folder called face record like this. So I have already done that. The other thing I need to do is remember we talked about HAR classifier files. The HAR classifier file is a collection of faces and data around that has been already learned. These are data sets that allow the computer vision library to operate with and recognize faces. We need to have that file somewhere local that we can make use of. How do we get that? We can use the terminal window for that purpose. So we can, as it shows here, we have created the desktop, on the desktop, a directory called face record. We go to that recognition directory. We need to copy the HAR classifier file, which lives here, /user local lib python 3.5 dist packages cv2 data. This is where the file lives. And the file that we are interested in is called HAR cascade. Let's look at that file quickly. So I can actually physically go to this directory. And if you look at the file, the various files, you will see that there's all these HAR files out there. If you want to just look at somebody's, track somebody's eyes, then you would use this particular one called HAR cascade eye.xml. If you want to get somebody's glasses tracked while they're wearing it, you can use this eyeglasses one. If you want to use frontal face, which we are going to use, we can use the one called default frontal face. There's also body ones, left eye, right eye, license plate, smile, upper body, and this very whole set of things that you could use. But as I was telling you, these are just pure XML files full of data that has been already compressed and kept. They're not very large files. They can be called into a program very quickly. So we're going to make use of that. So the main one that we want is this frontal face default.xml. So that's the one we must copy, and hence we can say cp, which is copy this file, and then dot. Dot means where I am currently, which is in on the desktop face record file. So at the end of this exercise right here, you should be having a folder. In the folder, you should have this HAR cascade.xml file already copied. Next, we're going to start writing a little code, and I'll go through this code very quickly. How do we write code? We go to Python screen like this. You don't write code here in the shell window. You go file, and just like we did a little test program before, we're going to go and create a new file like this and start typing. I already have typed this, so I'm just going to load it once more. So I will go through this test program, and let's first look at the end result of this. That's all. You'll be surprised to know that is all you need to do, enable facial recognition. Let me try to run it and show you, and then I'll step through the code. So number one, when I run this, maybe I didn't hit the run button yet, sorry. Once I run this, it'll start looking at my face right there, and as I'm moving around, it's going to track with a green rectangle wherever my face is. Even if I'm moving, my Raspberry Pi camera is able to track it. Right? So that's what we want to get to. How did we do that? So that's the more important part. So we talked about the OpenCV library that we downloaded. You must have an import in order for you to detect. The first thing we do is capture. We use this command from the library called video capture and save the frame buffer, whatever is coming from there, into this captured video stream. This is a stream. We also use we set up the cascade classifier. The reason we have this file saved in the same directory as the Python program file is because I can quickly get to this, and I don't need any path. I can straight away call it like this. I have the XML file there. All I'm doing here is load it into as a cascade classifier so I can make use of it. I'm calling this instance, the loaded instance, as face cascade. Then, as I'm streaming, as I'm getting the video buffers, while true, that means continuously, I'm capturing or reading from cap, the video stream, frame by frame information. So I'm capturing one frame, very quickly. I'm capturing these frames. All I need, actually, if you use colors, it'll slow the process down. It's a good idea to convert everything to grayscale because we are only interested in eyebrows and where darkness, black and white images or gray images is what we're looking for. So the first thing we do is take that frame, do a BGR to gray command. That means change blue, green, red to a gray shade. That's what we are saying. Now my new frame that I just captured is a gray frame. Then I call this on the face cascade, the HAR cascade, detect multi-scale. This is the main command that allows you to look for faces. What it returns back is faces, not one face. If I had two people here, I would be able to get two rectangle coordinates. A face itself has four things: X, Y, W width. It's actually returning squares. So it's returning the start point of the square and the width and the height of this rectangle where the face is. So let's say I get two faces back. For each of those faces, I am drawing it this command This is RGB. So I'm drawing a green square with a frame width of 2, and I'm just putting x comma y and x plus w and y plus h to draw that rectangle. I'm using the rectangle command to do that. So every frame I am drawing this again. I'm also printing what faces are found. This part is just, if I hit the Q button, it will quit the loop and then it will release and destroy. So that's as simple it is for us to do a very quick Raspberry Pi um, webcam based machine learning camera detection of faces. So I'll try this one more time and show it to you, and it does fairly good draw. Even if I am moving around, I'm kind of looking at it, and it'll, even if I move around, it can do a very good job of that. Okay, hope you enjoyed this session, and we can pause right here. Thank you very much.